In this recording, I'm going to discuss three very basic classification model, KNN, decision tree, and SVM, and how to use it in RapidMiner. We're going to start with our data set. So since it's a classification problem, we're going to need to use a categorical variable as an output. Similar as regression model, we will need to set or change the role for our target variable into label in RapidMiner. We also need to select the specific attribute or subset of attributes that we would like to use. So again, we start from our retrieving our data set, and we're gonna select the specific attribute. In this question, I selected just three attributes, smoker region and the children. So for this problem, I would like to classify smokers and whether a person is smoker or no based on children and the region. Children is a numeric variable and the region is a categorical variable. And smoker itself, that's a categorical variable, which fits the requirement of a classification problem. After that, we're going to set the role because after I read the data, all the columns are marked as a regular column. We're gonna need to pick the output variable that we just mentioned, which is a smoker, and set the target role to label and indicates that it is the output variable, so RapidMiner can read it. And then we can apply our three models. We're gonna start from our KNN model. Let me enable this one. Our KNN model, KNN is a very simple operator, and in RapidMiner, you can simply search KNN and you can see that it is under the lazy category under predictive analysis in RapidMiner, and you can simply drag this operator to your process. It only asks for one input, which is our training data set. We only need to connect our example set from set row into KNN operator. And then the KNN gives us two outputs. One is our example set, and another one is the actual model. So let's just see how it looks like. After you run the model, you will see it returns you two tabs, and the second tab doesn't show anything. The first tab, it just tells you what model it ran. It's the 5 nearest neighbors because by default, we set n equals to 5, or k equals to 5. And there are two, that is certain number of examples, so observations in our data set and how many categories we have, and what is the label of the category. Those are the information KNN model returns to us. Because KNN model, it is not a structured model, that's why we call it a lazy model. There is no actual model. So we don't see any graph, we don't see any mathematical formula. It only gives you the information of the model. For the model itself, the KNN operator, and you can do some settings. It provides you some parameters and the number of k and major tabs, what kind of major you would like to use, and also what is the distance measure. As a beginner, you can just keep it as a default, and if you change the major tab, and you're gonna see different results. Probably it depends on your data set. Now, another thing we want to know is that whether our KNN model works and how it can help us to predict the label for our data set. A simple way that we can do is we can use another one we call the applied model, and that is a operator we actually used it before. It's just called apply model. That is an operator we can use to apply our learned model on the data set. Again, apply model asks for two inputs. One is the actual model, another one is our import data. And we can, for illustration purpose, we can simply link our model and the example set from KNN operator into our applied model. We can further link the two outputs from applied model into our result node. It only gives us two. One is a labeled data, another one is the actual model itself, and the second one is the same as the model output from KNN operator. So we just run that, and we can see here's a model, and here is the example set with a predicted label. After we run the model on our data set, and we give the data set as an input to our applied model. Applied model will, based on other input variables, our children region, it's gonna make a prediction on each observation and to see whether it is with the label yes or no. So you can see that the model is okay based on what I see. For most observations, it have the correct prediction, and the predicted label and our actual label, they are the same. So that is a very intuitive way and simple way just to show you the model works, and it can do the actual prediction. So that is for our KNN model. It's pretty simple. And now let's take a look on our second model, decision tree model. The decision tree model, again, similar to KNN, it only takes one input, which is our training data set. So we just link the same thing. And it also gave us a output, the model, and the example site. We can also use apply model in order to take a look on the predicted label and compare it with our original label. And then let's see how the model looks like, and let's see how the predicted value looks like using the apply model. Okay, after we run that, you can see here is a model, which is an actual decision tree, and another tab shows you the predicted label. So this one is similar to KNN, and you can make a comparison on the prediction and the and the actual label. For the models, you can see the tree structure and see how RapidMiner treats your features and which feature use to split your tree and your data set. So we can read the tree structure from the top, which is a root, and that make use of our region variable, and our region variable is a categorical variable. So we actually have 4 categories, and when RapidMiner decision tree is split into 4 branches. And for each branch, let's take a look on this northeast branch. And the next criteria are gonna be children. Children, because that is a numerical variable. RapidMiner gonna help you to set the threshold. Here, the first threshold is 3.5. And to see whether you have a children larger than 3.5 or less than 3.5. If it's larger than 3.5, you're gonna go to this leaf and with a no, with a label no. If you are less than 3.5, you're gonna go to the next level in the split again. And we still use children. We split again based on different threshold, and we keep splitting to the end, and those will be our nodes. And for the nodes, you can see the 2 colors of bar, mainly because we have 2 categories, yes and no. And yes represented by blue, and no is represented by red. And again, for each leaf, you may have a mixture of 2 labels. And then what it does is that it's gonna assign the actual label based on the majority. So here you can see all the 4, the majority is no. The red bar is longer than the blue one. That is why you see the label no here. And then for other leaves, we then read it in a similar way. And that will be the structure of our decision tree. If you feel it's a little bit hard to read all those conditions and how the machine help us to split the data set, you can go to the second tab called description. Description, it shows you a textual structure without the actual nodes, and it's not that large. And you can simply read it from the first level and mark which level it is. And it gives you the indent. And you can read the first level conditions, second level condition, and third level until the end. So at the end, for each node, you're gonna see how many yes and how many no you have, and what is the actual label the machine assigned based on majority. So that is how we can read the structure of the decision tree. Let's go back to the decision tree operator. In the decision tree operator, there are a lot of things that you can adjust, and there are the parameters. So by default, there are two things that are checked if you just put your operator here. The applying pruning and the applying pre-pruning are checked. And you can also adjust the criterion you want to use to split your decision tree. There are different measures. We can use information gain, we can use a Gini index or something else. And again, if you choose a different criterion, the structure of your tree may change. So here I just choose information gain, and you can also control the maximum dips, and just to make sure that your tree will not growing too large. And I just use 10, but apparently my tree is less than 10 levels. So I think it's gonna stop if it meets other stop criteria. And you can choose to check applying pruning, apply pre-pruning. It's gonna help us to prune the tree, especially the pre-pruning. It shows a minimal gain value, minimal leaf size, minimal size of split. If your data set already meet all the requirements, if it's smaller than the minimum threshold, the RapidMiner will not split the tree for you. So let's just see how it looks like if I check both. After I run that, you will see that I only have one node and nothing split. And mainly because that's my data set already made those requirements. So the machine gonna consider that your data set, I don't need to split it anymore, and it's already good enough. So you don't need to do any process. And it depends on your data set. Some of you may have, if you just want to do a practice on decision tree, but you have a very good data set. And if you just keep the default setting, you may not be able to see a tree structure. In that case, you can just uncheck this too, and to make sure you will be able to see an actual decision tree structure and make sure the machine process your data properly. That is a second one for our decision tree model. Now let's take a look on the third one, our SVM model. SVM model, you just search SVM, and it called support vector machine. You can use a support vector machine without parentheses. It just is a simple one, and to do your analysis. And again, similar for the support vector machine. It takes one input, it gives the outputs, and we can do apply model in order to see the predicted label and the model itself. There is one more thing that if you link our data set with support vector machine directly, you will see an arrow here. It said potential problem detected because it cannot handle polynomial attributes. And that is mainly because that support vector machine, you can consider it as a pure mathematical model that makes use of mathematical formula. So if it is a mathematical formula, we can only use number, but we cannot use label. For the output variable, that is okay if your output is, we know the output is a categorical variable, and if it's polynomial, it doesn't really matter for support vector machine. But for your input variables, if it includes polynomial attributes, or if it includes some non-number labels, you cannot use it directly with a SVM operator. So that is why, in my case, I added one more thing called the nominal to numerical, trying to convert our nominal attributes into numerical. And here you can select, I just select, we have two, region and the smoker. So both are nominal type. But for smoker, that's the output. So I don't need to change anything. And for region, that is the one we would like to change because that is the input variable. So I can change my region to numeric. Actually gonna use dummy encoding. And then we can do our SVM. Now you can see the arrow just disappeared. So I'm gonna run our model and let's see how it looks like. So that is how the model looks like. It's still, that's a little bit hard to read for support vector machine. It just shows you the weight of your input variables, and we have 4 regions because that is categorical and we already converted it using dummy. So you're gonna create 4 dummy variables for us, and children, that's just 1, since it's children itself. And it is a little bit hard to see. It provides you support vector virtualization and just showing a scatter plot of your data. And it shows the yes or no is different colors. And you can see how it helps you to separate your data. But if your data set is too large, that's really hard to virtualize the support vector. And if you have more than 2 input variables, and it's hard for you to see anything. But we can see, just like KNN, we can check the result from applied model. We can see the predicted value and compare it with our original value. So that is how it looks like. And those will be our input variables. And for support vector machine, again, if you click it, there's something else that you can adjust, including the kernel tab. And you can adjust the kernel to some other shapes, and there are some other parameters that you can check to adjust the actual shape of your kernel. Again, for the kernel function, depends on your data set. If your data set have a certain pattern that a linear boundary doesn't work, and you can change the kernel tab. Sometimes when you change the kernel tab, it might give you better results. So let's say polynomial, and now you're gonna see the similar thing. It looks a little bit different, and our prediction looks different. So that is how the kernel function may affect our SVM. To summarize, here are 3 models: the KNN, decision tree, and SVM. Only decision tree shows you a very clear tree structure that you can use and display in your report, and showing it as the actual output of your model. But all these 3 models can be applied on your original data set, just for you to compare your original label and your predicted label. For KNN and the decision trees, 2 are okay because they are not a pure mathematical model. They can take categorical variables without problem. But for SVM, if you have categorical variable, or in RapidMiner it's called nominal type, if you have that in your input variables, you cannot use it directly. You have to use a nominal to numerical operator to change your nominal type variables into numerical type of variables. And you can simply use dummy encoding in just like a regression model.